Thank you very much. Well, thank you very much for being able to present for the grand jury, and especially as the last one. I know it's a long time for you, a long day for you. Just that you see where we come from. This team was founded for this hackathon 2 months ago. There was nothing there. We were building our prototype in the hack, and the last 5 days we went crazy and bought and got a lot of other stuff done. For us, it's about shifting to rail. And we all know people use cars just out of habit. But we now have a historic chance, because of this Friday for Future and so on, that we have an increased awareness that people know they should not take the car. But we know from behavioral science that it's not only awareness, but it's also willingness. And to increase the willingness, we have obviously to increase the convenience. That's what this whole hack is all about. And now comes our magic sauce. Yeah? Up to now, we were only able to optimize the convenience based on the data of our customers, the train passengers. And what's now possible is we can have access to real-time data of our non-customers, of those who take the car. And by understanding them better, we can better position our services for them. That means, look at this, and it's really amazing. Yeah, this is the headquarters of Hack2Rail in Brussels. Carlo, probably you went here this morning, and here you see the real-time data of today, how the traffic is. You probably recognize that the circle around there are always a lot of traffic jams and slow motion. Yeah? And our first use case that we did during the hack was to make predictive scheduling based on AI to reduce the waiting time. And what did we do? We did build a model that predicts the movement, that makes an optimization of the scheduling, that looks at the results and then reinforces the learning. We have the whole code on GitHub. There's a QR code, and now Janis will also post the link. That means you can use the code, it's all yours. And when we now look, this is Paris, and we have simulated and analyzed that, and you now see the red dots. And red dots are those that wait too long. That means if you have people waiting too long, now they go on the train, then not other people will join on the rail. And then we did the optimization, and now you see there are blue dots that coming, that become green because they're still waiting in the level of tolerance, that it's okay. And then, because we have optimized the transcodal, now the train will come and pick them up before they have waited too long. Yeah? And that's obviously a big possibility of what we are doing here. Yeah? Obviously for passengers, but I also want to mention it's also for freight. Yeah? That means if you get a call, you want to put some freight on the tracks, we hear people complaining it takes too long. With this machine, you can do it higher flexibility and faster delivery. That means you also become more competitive on the freight area. A second use case we just discovered out of working on the data. We have seen here that in Paris, in an area, there's a lot of car traffic before the official schedule starts. That means just by putting one additional line in front, we calculated you can get 1.8 million euro extra revenues from those that take now the car. Obviously, you can also see where people are starting. On the left side, you see the green dots, that's where they start, and the red dots where they end up. And you see there's a lot of traffic. And if you go with the train, obviously you have to go through Paris. And now you can calculate how much business you could do if you would build a train line there. Yeah? And then decide if you want to do it or not. But building train lines obviously is very expensive. We can take an idea out of the playbook of IKEA. We all know the moment you build tracks, the property prices increase along the tracks. That means we can calculate how much property the prices would increase out of public data. And then you could finance the additional track by just buying some property before and then selling them with a higher thing. We have a lot of additional use cases just starting to work with the data. I just wanted to mention a last one. You already have optimized schedules for the big events like Garon Galot or the Paris Fashion Week. but a lot of local events that also disturb a little bit the schedule. And with AI scheduling, you can also do the long haul. You can do demand-based scheduling for those little things. Yeah? Now the question is, what would you get if we would win? Yeah. On one side, we do shift to rail. That means we work on the biggest lever because we're working on the non-customer data and optimize for them. And we see so much potential. Yeah? We see a lot of use cases for passengers and freight, and it's just starting. And therefore, we would be so thrilled to be able to work on this more if you would give us the honor to win this competition. Thank you very much.
Thank you very much for your pitch. Thank you. Now I will let Nicolas to ask the first question.
Great, Herman, thank you very much. I think very exciting and a lot of visions and North Stars, I'd say, where you want to get to. One very fundamental question I have is how do you obtain the data, especially, let's say, people data, given information security laws? How do you make that scalable from country to country?
Thanks for asking. This was a very big challenge for us. And last Saturday, we were not able to answer this question. But after we got into the final, we worked very hard on it. And we have a magic data source, which is totally GDPR compliant and which is fully available with 4.2 billion car data points every day in whole Europe. We built the API, and all the data you saw are real data from today in Paris. So you can challenge us in every city, Germany, France, whatever. I tested it at home in Appenzell in the Swiss mountains. It's working.
Thank you. Christian, you can ask your question.
Thanks, Dr. Herman and Mark. Very important to preach to the non-converted. This is comparing to road. What about planes? Scalable to planes as an alternative. We spend a lot of time going through security checks and all of that.
You know what? We prepared this pitch, but we just said it's not enough time in 5 minutes, but we have already fetched the flight data and made a calculation how much night trains, for example, for the long haul trips could generate business for rails. You are totally right. It was a matter of time.
Yeah, and pitch time. You can do point-to-point connections. That means exactly where a flight is only going from somewhere to somewhere, and with flexible scheduling, you can do point-to-point. That means you don't have those stops and the trains. Yeah, it's a huge complexity. You can only manage with AI, but we would be so thrilled to do that, competing with the flights.
Yes, Carlo.
I hope you hear me well because I had a problem with my bandwidth, but my question is that what you propose is quite interesting, but rail is not so agile. So we cannot simply anticipate a train or delay a train to adjust it. So I think the idea is interesting, but how you think we will be able to scale it up? Maybe in urban transport you can have a bus, you can have something like this, but in the rail system quite rigid. Do you have any suggestions? Or are you thinking about how this will work?
We were talking also during this week with a lot of responsible at railways. For example, Mr. Topal, that is the CTO of ÖBB, and he said he would start with the regional lines, because there you don't start with the high speed, you start with the regional lines. You can also integrate with the bus lines, and you start there. You gain experiences. That means you keep the high frequency, high speed lines as they are, but in the regional, at outer spaces and outer time, that means at the non-rush hours, you can do a lot. With that you start, you gain experience, and then perhaps with time you can do a flexible between passengers calculated and passengers flexible, and so on. But that's the way we have to learn, to be honest. Yeah, but on regional, it seems perfectly doable. And that's where we lose most of the people. In this high frequency areas, people already use the train. Yeah, we have to win those who have to take the car because they don't have good connections.